9EE, recycling materials. So obviously we want to recycle as much as possible, as many materials as possible. This way we're not using up finite resources as quickly, and we're not filling up landfill sites as quickly either. So they'd like you to know a little bit more about how to recycle different kinds of materials. Recycling metals is usually a fairly straightforward process. Once they're separated from other materials, you can just melt them down and use them again. They also talk about recycling glass, and now here again we find a difference between glass and the other ceramics, because most ceramics are not easy to recycle, but glass is a lot easier. It can be crushed and easily melted and made into new glass, and it takes so much less energy to make this recycled glass, so it makes sense to do it. Next, recycling polymers. Now, there are actually different symbols, and you will have seen these on different packages that you've had before, and these symbols are supposed to help us categorize them into the different kinds of polymer that they are. But it can be quite difficult to separate these out correctly and quite expensive, so the recycling of polymers is still not as common as it should be. We can recycle paper by basically washing it to remove all the ink, then filtering this water out so we get a kind of pulpy mess, and heating and mixing this together, squeezing it flat back into paper sheets again. Lastly, we can recycle concrete by using big machines that crush it all up. So this concrete becomes crushed rocks in itself, it becomes aggregate like we talked about before, and then this can be used to make roads, the foundations of buildings. Now we have a next page for 9EE, so we'll take a look at that too. Material failures. Now, as is often the case with making new materials, is that we don't realise that they have a property that can actually be quite damaging until later on. So some examples of this that they want you to think about are asbestos, which you've probably heard of. This was used in lots of buildings as a good insulator and because it's very fireproof, but breathing in the fibre dust from this can damage your lungs very badly and can lead to permanent lung damage. So we've had to replace asbestos wherever we can find it. Another issue that we've had is with something called CFCs, chlorofluorocarbons. We thought these are fine and safe to use in fridges and aerosols, antiperspirant sprays. But then we found out that they're actually reducing the level of ozone in the atmosphere. And we need that ozone layer there to protect us from harmful rays from the sun. So when we realised it was reducing it, scientists came together, came up with regulations against the use of CFCs in aerosols and in fridges. And now those ozone holes have started to close back up again, or have closed back up again in lots of cases. So that's great progress we've made there. They end off on a good note that we can find unexpected positive properties to a substance that we didn't realise that it would have. And their example is that somebody found out about a polymer that was actually quite weak and they decided to discard it, and then realised that it could stick and unstick quite nicely and be reused in that way, and it became the backing to post-it notes. Not all is lost.